Okay, so here we are now on the Cartesian vectors class. So as we have discussed last time, so we only analyzed those problems which involves two dimensions, which is the x-axis and the y-axis. But in reality class, the dimensions existing here in our environment or with the real problems, okay, is in three-dimensional, which involves the x-axis, y-axis, and the z-axis. And class, it is easy for us to apply the vector algebra or the operations of the vector algebra if our dimensions are in three dimensions. Okay? And class, it is much easier if we express them in Cartesian vector notation, okay, unlike in the scalar notation. So what really is Cartesian vector? So in this section class, we will be discussing or we will be presenting general methods on how to express or how to find the resultant force of a system which uses Cartesian vector notation. Okay, so, but before we discuss such things, let us first analyze what's the principle behind the Cartesian vector notation. So, remember class that in Cartesian vectors, so since we are using the three-dimensional, so para hindi natin makalimutan, so we are using our right hand in order to determine the direction of such axis or axis. So since we have a 3D or three-dimensional, so we will be using our right hand to become our coordinate system. Just like what you can see in the picture, we have there a right hand which or where your thumb, okay, represents your z-axis, positive z-axis, while your fingers, okay, so the remaining four fingers here, the pointer, the middle finger, the ring finger, and the what do you call this, pinky, okay, as you curl it, okay, as you curl it, the direction is from x to y axis, as you can see here, okay, here, this one. As you can see here, the curl of the four fingers is from x going to the y-axis. Okay? So, whatever the direction, this is your x, the z-axis, the thumb. And so, as you curl it, so this is the position of your x-axis and this is your y-axis, which means that this, how do you call this part right here? Is it your hand? I don't know what's this bicep. I don't know what's this part right here, but at the wrist, your wrist here represents your y-axis, while the curl is your the direction here is your x-axis. Okay, so if ever you forget, so just use your right hand. But then class, there are books that uses other, or the arrangement of your x, y, and z axis is different. Take note of that class. There are books where the thumb, okay, is y-axis. Okay, there are books like that this thumb represents your y-axis and this one is your z-axis, this is the y-axis. So merong magka-rumble. So just be aware of it. O baka kasi iba yung ano nila ginagamit nila. So baka ikaw rin na nagso-solve, so baka iba yung ano mo, ma-submit mo or ma-solve mo. Okay, kasi so you have to remember that will be our reference axis as we go through our analysis of our problems. Okay, now since we are using the Cartesian vector notation, so how are we going to express it if ever we are trying to solve for the rectangular components? So the vector will then be expressed like this. If, for example, we have a vector A, So it will be written as A is equal to A sub x plus A sub y plus A sub z. Take note class, this is rectangular components, okay? Where your A sub x is your x component, your A sub y is your y component, and your A sub z is your z component. Now take note, this A sub x, this A sub y, and this A sub c are just magnitude. Okay, these are just magnitude class. Now, how are we going to integrate, or how are we going to place its direction? It's because, as we know, this vector A is a vector, so it needs to have a direction. So how are we going to express it with direction already? Again, this expression, as you can see here, is just magnitudes. Okay, these are just magnitudes. Now, in Cartesian class, okay, we have what we call Cartesian unit vectors, where we use this I, J, and K as our directions. And take note that I is the direction used for the x-axis, while for the J, we use it only for y-axis, and for K, we only use it for z-axis. Okay? If you could recall in our previous discussion, so we only use I and J, right? Because we only have 2 dimensions, x and y. But in this case, we have 3 dimensions, so we will add another unit vector, which is the k, and it is the unit vector or the direction of your z-axis. Okay? Now, so we have to integrate this direction into our rectangular components. So we will simply put this I to our x component, our j to y component, and our k to z component. And it will look like this. Okay? So instead of having ax plus ay plus az, so we will have here already our ax here, axi. So this is our magnitude and direction already. Ayj, your magnitude for the y component, and this is the direction of your y component. And for the az, this is your magnitude, and your k is your direction. So this is already, class, our Cartesian vector representation for our vector A. Okay, so mind that this is the format. So not all the time, class, that the given is vector A. So it could be that our given is, it could be force. Of course, usually force is because we are in engineering mechanics, so we are mostly solving forces. So it could be that instead of A, so we will be using F. So it will be F is equal to F of xi plus F sub yj plus F sub zk. Okay? Again, this A here represents a vector. Okay? Any vector. Okay? Now, if, for example, class, we are given a vector A, and it is already in this expression. Ito yung given. Okay? You are asked, what is the magnitude based from this given vector? So, how are we going to solve it? So, the same class, we will be solving it using this formula, the square root of the sum of the squares of each components. So if you could recall, in your 2-dimension, your x and y, we have used the Pythagorean theorem, right? We have solved the fx squared plus fy squared, and then get the square root of it. So in this case, the same. The only difference is that you have added the 3rd dimension, which is the z component. So you just add the square of the z component, and then just get the sum of it, and then you have to get the square root, and you'll be able to get the magnitude. Take note, class, that the magnitude here is symbolized as it has a bar on it. Okay, it is contained in a bar, which represents that it is our magnitude. Okay, now let's say, for example, as you can see here in your figure or in your diagram, let's say that our x component is right here, okay, which is of course along the x-axis, and let's say that this is the y component and this one is the z component, of course. But take note that our given here are all positive, but there will be cases, of course, class, that your x component, or it could be your y component or your z component, has a negative value component. Let's say, for example, that your x component is negative, so it will be plotted here, right here, because this part is your negative y component, negative x component rather. This is your negative x. While if for example in the y component it is negative, so this part, this is your negative y component. But if for example your z component is negative, so you will plot it downwards this way. Okay? Negative z. So what we are showing here is just pure positive, or all are positive. Okay. Where am I saying again? Okay, so once you get the magnitude, okay, so this is how it will look. Okay, so this one, this is your location of your magnitude of your force, or it could be your vector A. Okay, so you simply trace, if this is for example your, let us first delete this one. Okay, so let's say that this is your x component, this one. So all you have to do, this is your x component, so all you have to do is trace it here, this one. And then if this is your y component, trace it here. And while this is your z component, okay, so you have to trace it here, there, for example. So you have to intersect the three components. So you first intersect the x and y, which the resultant is this one, the resultant. And after that, you have to lift it up if it is at positive axis, there. So you have to lift it up there, depending on the magnitude of your z component. But if it is downwards, class, if your z component is downwards, let's say this one, your z component is right here, okay, this one. So you have to bring down this arrow here. You have to bring it down here, this one, which will become like this. So your vector A will be like this. Okay, this one, that. Okay, so you have to intersect the three components. Now, here's the fun part. How about when it comes to the direction? Okay, if you could recall, in the two dimensions, you have to use the components, of course, in order to solve for the angle, which uses the tangent, right? You have to get the arctan of the y component divided by the x component. But take note, class, we are now in the three dimensions. So what will happen to the solving, or for the formula for the direction? Now take note, class, as you can see here in our figure, okay, we now have three directions. Okay, three directions of our what? Since we have three axes, so our vector A, this is our vector A, class, can be, okay, wait, sorry, this one, it can be described in three, with respect to three axes. So it could be that you describe your vector A with respect to x, it could be that you describe it with respect to y, or it could be that you describe it with respect to z. Now, if you want to describe your vector A with respect to the x-axis, you will use the angle, which is the alpha. As you can see here, class, alpha is your direction of your vector A from your x-axis. So if you measure from x-axis going to your, this is your vector A, so it will be defined as alpha. Take note, as alpha, Greek letter alpha, and this one is alpha. Okay, and you'll be able to solve it using the cosine. Cosine alpha is equal to your x component all over the magnitude of your vector A, or your final, or the resultant of your, or really the vector itself. Again, magnitude magnitude of your vector A. You just divide your x component divided by the vector A. Again, that is how you solve for the alpha. Now, how about the beta? What is the beta? Beta class is another Greek letter which we used to represent the direction from your y-axis. Take note, from y-axis. So if you want to describe your vector A from the y-axis, if you want to measure it, so from, this is your y-axis, right? So if you measure it from here, going to your vector A, this is your vector A, so you will be using the angle beta. Okay, angle beta. And you'll be able to solve that by dividing your y component by the magnitude of your vector. Okay? So let's say, for example, you are given force F. So all you have to do is get the y component, divide it by the magnitude itself, and then get the cosine or the arc cosine of that. Okay? Now, while for the direction of z-axis, we represent it by the what do you call this? I forgot what kind of Greek letter is this. Gamma. Yeah, it's gamma. Greek letter gamma, or parang y siya. So from the z-axis, if you want to measure it, or if you want to describe your vector A from z-axis, so the angle is gamma. Okay, and you'll be able to determine the value by dividing the z components by the magnitude of your vector. So cosine gamma is equal to AZ divided by your magnitude. So take note, class, tatlo. We have 3 direction in each. Okay, unlike in the 2 dimensions that we only get the theta. Okay, the theta only. So in this case, we don't use the theta because theta is represented only in the 2 dimensions. But in this case, alpha is the angle that describes your direction from the x-axis. Your beta describes your direction from the y-axis, and your gamma describes the direction of force or your vector from the z-axis. Okay, so remember, class, that if again you are given this vector, okay, let's say vector A, and you are asked for the magnitude, so just simply use this formula, the square root of sum of the squares of the components. But if for the direction, so just use these 3 formulas. Okay, now what if you are asked what is the value of the unit vector? Okay, what is the unit vector or the direction itself of the vector? Kasi class, this alpha, this beta, and this gamma, this is the angle. Okay, this is the direction with respect to each of the component or the axis. So halimbawa, itong alpha, ito yung direction with respect to x. Yung beta naman, yung angle with respect to b. But yung y is yung with respect to z. But what if you are asked for the unit vector itself, the direction itself? Okay, so what will you answer? So it will be expressed, class, using this one, which is in the unit vector. Class, this symbol here, u sub a, is the unit vector of vector A, or unit vector A. Okay, and you'll be able to solve that by simply dividing your vector A by the magnitude. Take note, class, the difference. This, the one in the denominator, is the magnitude, while this A here at the numerator is the vector itself, which is expressed here. This one, this is the A. Okay, so this whole expression here, you will divide it by your, or by the value of your magnitude. Take note, class, that magnitude is just a number. Okay, so you will divide this expression here by the magnitude, which is, or it will look like this. So if your A, okay, if your A is AXI plus AYJ plus AZK, you divide them by your magnitude. But as you can see here, class, in our equation or our format, we divide it individually. Each of the components, we divided it by the magnitude. Okay? So, this simply means, class, that if you want, or if you are asked to solve for the unit vector of that given vector, you simply divide the x component by the magnitude and then just put I. Okay? Now, what else can we find in here? So, if for example, the x component is not given, or even the magnitude, the only given, for example, is the direction with respect to each of the components. So what are you going to formula, or what are you going to do? So take note that you can also solve for the unit vector of A by simply getting the cosine of each angle. So cosine of the alpha, cosine of the beta, and cosine of the y. Can you follow? Because class, if you could recall, this expression here, x component divided by your magnitude, is equal to your cosine theta, or your cosine alpha rather. If you could recall here, there, this one is equivalent to cosine alpha. So since this quantity here is needed for our unit vector, so why not just simply use this if this is available? But if not, so just use this component, x component, and then your magnitude. So going back here, so again, this quantity here, so just the same here, and then just put I. So this one is just the same here, and then put J. And then this one, the same here, and just put K. Okay, so that's how we can solve for the unit vector of the given vector A. Okay, now that's for the expression of the unit vector. Now, how are we going to solve? Let's say, for example, you are given two directions. Let's say you are given beta, you are also given the gamma, but you are asked to solve for the alpha. You don't know this. How are you going to solve it? Now, you have here the expression, class, that the cosine of the angle alpha plus cosine squared of the beta plus cosine squared of the gamma is equal to 1. Which means, class, that you may be able to solve for the value of alpha if you are given the two values of beta and gamma. How? So you simply subtract. Okay, if you transpose this one, so what will happen is you have 1 minus, so you have here cosine squared beta minus cosine squared gamma. Okay, and for you to get the value of your alpha, so what we will do, so we will simply, kasi class yung cosine squared alpha means cosine alpha and then square. So therefore, you have to get the square root of this and then get the arc cosine. Can you follow? Again, cosine, I am sorry, that is so, I cannot write well here in the PowerPoint. Cosine squared alpha is simply cosine alpha squared. Okay, so in order for you to solve for the value of alpha, so you first have to get the square by getting the square root, and then so that your alpha will become, or will be left, so you have to get the arc cosine, which is this one. So arc cosine of the square root of 1 minus blah blah blah. Again, if you are required to solve for the alpha and given beta and gamma. Anyways, we will be having examples regarding that. But always remember that the sum of the squares of the cosine of each direction is equal to 1. And this expression, ayan. Okay? Now, what's the other way on how we could solve for the vector A or even vector? So we have here a general formula class of our vector notation, Cartesian vector representation. So if you are given here your vector A, this is your vector A. So if you are asked to represent or to express it in Cartesian vector notation, so you will be needing the magnitude. This is the magnitude, and you have to multiply it with the unit vector. Okay, unit vector, which is u sub a in this case. But for example, you are given force F. Given vector force, vector force. So this will be unit vector of F. Okay, we only use a here to represent any vector. Okay, again, for you to express your vector in Cartesian vector notation, so you simply need the magnitude of that vector times the unit vector of that vector. And to do that, so simply your unit vector is simply cosine alpha I plus cosine beta j times cosine gamma k. And you just multiply it to your magnitude. That's why we have here the distributive factor. So, nag-distribute na siya. So, that's how. Okay? And from that class, we can now express your vector A as this. A sub xi plus A sub yj plus A sub zk. Which means that, ano ibig sabihin? It means that your A sub x, okay, take note, that's this one. Okay, let us first erase this part. Okay. Look closely, which means that you'll be able to solve for your alpha or your x component by simply multiplying your magnitude to your cosine alpha. Okay? And your y component by simply multiplying your magnitude to your cosine beta. And your z component by simply multiplying your magnitude to your cosine gamma. Okay? So, let's say for example, given the alpha, beta, and gamma, as well as the magnitude, so if you are asked to express it in Cartesian vector notation, so this is what you will use. Followed? I hope that you followed it. And that's it for the Cartesian vector representation.